Welcome, my dear students. This is the 5th class that I am taking. Before I begin today's class, I would like to just say that on the previous class we have exclusively talked about units and dimensions, and we have understood a very important principle called principle of homogeneity, and thereafter we have seen what are the advantages of dimensional analysis. So this is what all I have done in my previous class. So in this class I shall be extensively doing few numerical problems on dimensional analysis, that is involving dimensional analysis. So I have just written the questions on the paper so that I can reduce the time a bit. So let us try to solve the first problem. The problem says the distance traveled by a particle in time t is given by x equal to a plus bt plus ct square plus dt cube. Find the dimensions of a, b, c and d. Fine. So solution. Now here x, you see it is told that x represents the distance traveled. So immediately we can imagine that the dimension of x will be nothing but length, L to the power 1. So dimension of x, this is the dimensional representation of x, this will be m to the power 0, L to the power 1, t to the power 0. Why? Because this x represents distance. And what is the dimension of distance? It is L to the power 1 or simply L. Now I have to find the dimension of ABCD. Now here there is t. T represents time here. So obviously the dimension of t is known to us to be m to the power 0, L to the power 0, t to the power 1. Now if you remember the principle of homogeneity, it stated that if the dimensions of all the terms are same, then equation will be correct. Now it is the given equation. That means I have to consider it to be correct. Now if this is the correct equation, then the dimension of x has to be equal to dimension of a, has to be equal to dimension of bt, has to be equal to dimension of ct square and so on. So that means dimension of x has to be equal to dimension of a. What it means that dimension of a will be equal to dimension of x, and which is nothing but L to the power 1, or I can write it to be like this, m to the power 0, L to the power 1, t to the power 0. Dimension of bt has to be same as that of x. That means what? Dimension of bt has to be same as that of x. That means m to the power 0, L to the power 1, t to the power 0. Fine. That means from here I can write dimension of b will be equal to m to the power 0, L to the power 1, t to the power 0 divided by dimension of t. Dimension of t is t to the power 1. Fine. So dimension of b will be what? It will be L to the power 1 and t to the power minus 1. So this is the dimension of b. Fine. Now what is the dimension of ct square? Dimension of ct square again has to be equal to dimension of x, that is L to the power 1. So definitely it says that it implies that dimension of c will be equal to dimension of L to the power 1 divided by dimension of t square. T square, that means t to the power 2. So it is nothing but m to the power 0, L to the power 1, t to the power minus 2. Similarly, what will be the dimension of dt cube? So dimension of dt cube again will be equal to L to the power 1, because dimension of dt cube has to be equal to dimension of x. So clearly it indicates that dimension of d will be equal to L to the power 1 by t cube. So t to the power 3. Don't forget to give the third bracket. So it will be m to the power 0, L to the power 1, T to the power minus 3. So we have found out the dimension of A to be L to the power 1 or m to the power 0, L to the power 1, T to the power 0. Dimension of B to be L to the power 1, T to the power minus 1. Dimension of C to be m to the power 0, L to the power 1, T to the power minus 2. And dimension of D to be m to the power 0, L to the power 1, T to the power minus 3. So our first problem is solved. I hope you have understood. Now let us focus on to the next problem. The problem says, just a bit, I have to set the camera a bit. Yes. The problem says, let us focus on to the next problem. It says, if the centripetal force is of the form m to the power a, v to the power b, r to the power c, find the values of ABC, where this m represents mass, v represents velocity, and r represents nothing but the length, actually. So let us see how we can solve it. Centripetal force. So I am not going into details of centripetal force and all that, but you can trust me that centripetal force is also basically a force. So when we are considering the dimensions, centripetal force, the dimension of the centripetal force will be equal to the dimension of the force. So basically the equation that I am having from this equation is that the force, dimensionally if I have to write force, what has been given to me for? Force is of the form mass to the power a, then velocity to the power b, and then length or distance also we can say, no problem, to the power c. This is basically, dimensionally if I write, this is the form of my equation. I can even add a dimensional constant, proportionality constant, not a matter, because constant quantity have got no dimension, so it will not hamper in my dimensional analysis. So now again we are applying principle of homogeneity. Now what is the dimension of force? Dimension of force is m, L to the power 1, T to the power minus 2. So this is the dimension of force. That has to be equal to mass. So it is m to the power 1, L to the power 0, T to the power 0, whole to the power a. Velocity, m to the power 0, L to the power 1, T to the power minus 1, whole to the power b. Length, m to the power 0, L to the power 1, T to the power 0, whole to the power c. Now if we just compare the powers of MLT on both the sides, what we get is that a, b and c are there. So basically it is what? This is basically m to the power a, 0, 0, so no question, L to the power b plus c, because from here b and L to the power 1 to the power c, b plus c, T to the power minus b, fine. So now if we compare this left side with right side, what we get? A equal to m to the power a, m to the power 1, so a becomes 1, b plus c becomes 1, and minus b equals minus 2. That means b equals minus b equals minus 2. That means b equals 2. So a is 1, b is 2. That means what will be the value of c? C will be minus 1, because if I put the value of 2 here, so 2 plus c equals 1. That means value of c is minus 1. So we have found the values of sorry. So we have found out the values of a, b and c, and this is what was asked in the question, to find the values of a, b and c. Now I move on to our third problem. Yes, the problem is that the problem asks to check the dimensional consistency of the relation Fs equal to half m v square minus half m u square, where s is the distance moved, u and v are the initial and final velocities, and F is the force acting. So what I have to do is that I have to check the dimensional consistency. That means I need not to find the dimension actually, but I have to see whether dimensionally this particular relation is correct or not. Whether dimensionally the relation is consistent or not. This is specifically the meaning of the question. So which question I have been supplied? Fs equal to half mv square minus half mu square, where m represents mass, v and u represents velocities, be it final or initial, dimensionally they are same. F represents the force and s represents the distance. So let us see. So I write its solution. Fine. Now again, everything has to be dealt with the help of principle of homogeneity. If it's a correct equation, then dimension of Fs as a whole, the term we are considering, dimension of Fs has to be equal to dimension of half mv square, has to be equal to dimension of half mu square. Now what is the dimension of Fs? Let us find out. Force into displacement. So what is the dimension of force? M L t to the power minus 2. Dimension of S, S representing distance. That means it will be L to the power 1. So the dimension of f of s is m to the power 1, L to the power 2 and t to the power minus 2. So this is all the dimension of fs. Now what is the dimension of half mv square? Half has got no dimension, so no need to think of it. So dimension of m, it is m. Dimension of v square, v is L t to the power minus 1 whole square. So this becomes m L square t to the power minus 2. Now let us see the dimension of half mu square. Half mu square. So half has got no dimension, just like previous term. Dimension of this m is m and u representing velocity, initial velocity, but basically dimensionally when we consider just it's a velocity. So L t to the power minus 1 whole to the power 2. So what do we find? M L square t to the power minus 2. So what we find is that dimension of each and every term, dimension of fs is this one, dimension of half mv square is this one, and dimension of half mu square is this one, and all these three are same. And this is what has been told by principle of homogeneity, that if we have a correct equation or correct scientific relation, then the dimension of each and every term has to be same. And this is what exactly we are finding. So we can say that yes, this relation is inconsistent, is really consistent with the dimensional analysis, and therefore we can say it's a correct scientific equation. Now let us focus on to the next problem. The problem says, given that the displacement of an oscillating body is expressed as y is equal to a sine bx plus ct plus d, find the dimensional formula for a, b, c and d. ABCD. You follow this question. The displacement of an oscillating particle is expressed as y is equal to a sine bx plus ct plus d, and what we have to do is that we have to find the dimensional formula for ABCD. That means first we have to find the dimensional formula for A, B, C, D individually, and thereafter I have to write the combined dimensional formula for A, B, C, D. That's all what has been asked in the question. So let us try to solve it. Now y is representing displacement. So clearly it indicates that the dimension of y is nothing but same as that of distance L to the power 1. So I can write m to the power 0, L to the power 1 and t to the power 0. Now I think you have remembered that angles have got no dimension. They are dimensionless. That means as a whole bx, ct, d all are dimensionless. That means they are dimensional m to the power 0, L to the power 0, t to the power 0. But x, dimension of angle bx as a whole dimensionless. It does not mean that b has also got no dimension, x has also got no dimension. No. As a whole, the term, the angle is being represented by bx. So bx as a whole will have no dimension. Then clearly we can say that the bx as a whole dimension of bx is m to the power 0, l to the power 0, t to the power 0, no dimension. But what will be the dimension of x? Dimension of b? It will be m to the power 0, l to the power 0, t to the power 0 divided by dimension of x. And dimension of x is l to the power 1. So it will be m to the power 0, l to the power minus 1, t to the power 0. What will be the dimension of ct as a whole? Ct as a whole will be dimensionless. So dimension of ct will be m to the power 0, l to the power 0, t to the power 0. So what will be the dimension of c? This will be m to the power 0, l to the power 0, t to the power 0 divided by dimension of t. It is t to the power 1. So what I have, dimension of c to be equal to m to the power 0, l to the power 0, t to the power minus 1. What will be the dimension of d? Definitely, I think you can imagine just by looking into it, it will be completely dimensionless because it is again a part of the angle. So we have got the dimension of a. Oh, sorry. What will be the dimension of a? I forgot. This quantity as a whole is dimensionless. On this side we have the dimension of l to the power 1. So definitely a will have the dimension as same as that of the dimension of y. That means dimension of a will be equal to same as that of the dimension of y. That means l to the power 1. Whenever we are writing l to the power 1, it is wise to write m to the power 0, l to the power 1, t to the power 0. Just to make you understand, I am writing in short. So we have got all the dimensions of all the parameters starting from a, b, c, d. So what will be the dimension of a, b, c, d? Because I have to write dimensional formula for a, b, c, d. Dimension of a is l to the power 1, b is l to the power minus 1, m to the power 0, l to the power minus 1, t to the power 0, so it is l to the power minus 1. C is t to the power minus 1 and d is all 0. So basically it will be what? It will be m to the power 0, l to the power plus 1, minus 1, 0, t to the power minus 1. So this is the dimensional formula for A, B, C, D. Now let us try to solve this problem. In the equation y is equal to a sin omega t minus kx, obtain the dimensional formula of omega and k. Obtain the dimensional formula for omega and k. So what we know is that angles, once again I am writing, this is just what we have already done on the previous problem. Angles are dimensionless. Fine. Now here the quantities, which quantities represent the angle? Omega t and kx. That means omega t, fine, it will be a dimensionless quantity. That means, okay, dimensionless quantity. So what will be the dimension of omega? It will be that dimensional quantity divided by the dimensionless quantity divided by the dimension of t. T represents time. So here I will have m to the power 0, l to the power 0, t to the power 1 because that is time. So here what I can write, dimensional quantity has got no dimension. So I can write m to the power 0, l to the power 0, t to the power 0. No dimension. Or even in some, we can even write 1. There is no problem. There is no harm. So it will be m to the power 0, L to the power 0, T to the power minus 1. So this is the dimension of omega. Now similarly, if you see kx, kx as a whole will be dimensionless. That means I can write m to the power 0, L to the power 0, T to the power 0. So what is the dimension of x or dimension of k? So dimension of k will be equal to m to the power 0, L to the power 0, T to the power 0 divided by dimension of x. So it will be m to the power 0, L to the power 0, T to the power 0 divided by dimension of x, and dimension of x is what? L or L to the power 1. So this is again equal to m to the power 0, L to the power minus 1, T to the power 0. So this is the dimension of k, because I have to find the dimensional formula of omega and k. So dimensional formula of omega is m to the power 0, L to the power 0, T to the power minus 1, and dimensional formula of k is m to the power 0, L to the power minus 1, T to the power 0. So I hope you have understood this problem as well. Now let us solve our today's last problem. The problem says if the mass is represented by m, question says mass is represented by m and k represents force per unit length. Force per unit length. What is the dimensional formula for m by k? Just I have not written in sentence because this is very simple question. I am repeating the question. If small m represents the mass and k represents the force per unit length, what is the dimensional formula for m by k? This is what the question asks. So let us try to solve it. Fine. So dimension of m divided by k, this is what I have to write, or I have to find rather. So this will be equal to dimension of mass, because m represents mass, so it is m to the power 1, L to the power 0, T to the power 0. K divided by dimension of k. Now dimension of k represents what? Force per unit length. That means it is representing force divided by length. This is the meaning of force per unit length. So I can write it m to the power 1, L to the power 0, T to the power 0 divided by, what is the dimension of force? M, L, T to the power minus 2. Fine. Divided by the dimension of length. So if I solve it little bit, what I will have? M to the power 1, L to the power 0, T to the power 0. This L1 will go on the numerator divided by this one, M1, L1, T to the power minus 2. So the answer will be, it will be m to the, you see m to the power 1, m to the power 1, numerator, denominator. So I will be left off with m to the power 0, L to the power 0, L to the power 1, L to the power 1. So I will have L to the power 0. This L1 will get cancelled. T to the power 0, T to the power minus 2. So it will be T to the power 2. So this is the dimension of, or dimensional formula of m by k, where m represents the mass and k represents the force per unit length. So I stop my today's class here, and on the next class we shall be exclusively dealing with the numerical problems that usually come from the part of dimensional analysis or dimensional consideration. Thank you.